ever been berated for using the wrong measuring cup?
Why are there two different types? Is it really just to make more dishes?
No! If you fill a Pyrex to 2 cups of water, the measurement lines tell you when to stop. But because of surface tension, if you fill a cup measure with water, you'll get much more than a full cup.
This is liable to ruin anything from a birthday cake to those coveted banana pancakes.
So let's talk about surface tension.
Welcome to Fun with Surface Tension.
Let's take water as our primary example. Surface tension is caused by the charges on the molecular constituents of a liquid.
Water, known as H2O, is a molecule that has distinct positively and negatively charged regions. This is known as a polar molecule.
Just like magnets have a north and south pole that allow them to attract to each other, water molecules have a positive pole and a negative pole that allow them to align.
This slight attraction allows water molecules to create a shell on the surface of the water bubble. The energy in the attraction is able to overcome gravity until the weight of the water bubble becomes too great.
So now we can understand that the components of a liquid play an important role in the strength of the shell. Stronger shells hold greater volumes. What might happen if we saturate the water with salt ions?
The salt ions intercolate between the water molecules and, being independently charged, attract the poles of the water molecules. This ion-dipole interaction is stronger than the dipole-dipole attraction of pure water, thus creating a stronger shell.
The saltwater bubble is therefore larger than the pure deionized water bubble.
Interestingly, because drinks like Powerade are electrolyte solutions containing salts and water, they can also create larger bubbles than pure deionized water.
This effect is also quantifiable by measuring surface tension values. The surface tension of pure water is about 70 dynes per centimeter, while the surface tension of salt-saturated water is greater than 75 dynes per centimeter. Water with soap added thus has a much lower surface tension than pure water, and the bubble's shell is weak. A soapy water droplet is therefore much smaller than the previous droplets discussed.
Now let's talk about something more relevant to cooking. Oil has a much lower surface tension than water.
This is because oil molecules are non-polar long carbon chains that don't attract each other like water molecules.
Oil, therefore, cannot create a shell, and the droplet that is formed is only held together by viscous entanglements of the carbon chains.
The resulting droplet can be large due to the viscous entanglement forces, but no overhang is observed, as in the previous cases, due to the lack of surface tension.
Based on these observations, it can be assumed that a nonpolar small molecule would have very few interactions and would not be able to beat up into a droplet.
In fact, small nonpolar molecules such as acetone and ethyl alcohol, which is a main constituent of vodka, have very low surface tension and therefore do not create significantly sized droplets.
So back to the initial question. Is it really necessary to use special liquid cup measurers when cooking?
Yes! By quantifying the amount of beating on the top of the container for each liquid, we can see that the volume of each droplet is directly correlated to the surface tension of the liquid.
Now remember this next time you're cooking. Use cup measurers for dry ingredients and liquid measurers for wet ingredients.
Unless you're cooking with vodka. Then it doesn't matter.
Thanks for watching!
Be sure to join us next time for Fun with Stokes Drag.